Why do you eat? This is the first question I ask in my class in Bio 142, and I usually get a lot of different answers. People say things like, because I'm hungry, or because I like to eat. Sometimes people say, because food gives me the energy I need to have activities, or because I need carbohydrates or proteins, or some people say it's because I need vitamins or minerals. The various answers that people give to the question, why do you eat, fall into two main categories. One of those is energy. We eat in order to get energy. And the other is for building blocks. By building blocks, I mean the molecules that are used to actually build our bodies. So we eat in order to get energy, and we eat in order to get the materials to build the bodies in the first place. I'm going to start today by talking about energy, and energy is measured in calories. One calorie is the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. When we want to know how many calories are in a food item, what we do is we convert the energy into heat. We do that by burning it. So for example, I could take a nut and I could set it on fire, and I could measure how much heat is given off by that nut as it burns, and that would tell me how many calories are in that nut. If I were to use the heat in order to heat up a container of water, then I could simply take the amount of water that I had in grams or in milliliters, because with water has a density of 1 gram per milliliter, so I could just measure the volume of the water, and I could measure the starting temperature and the stop temperature in order to figure out how many degrees Celsius it had increased. This is the basic technique that's used in calorimetry. We take whatever it is we want to measure the calories from, we burn it, and collect the heat basically by letting it warm up a sample of water. By multiplying the size of that sample of water by the number of degrees Celsius in temperature change, we can end up getting the total number of calories that are in that sample. Now, the reason I have this page labeled the Martini Diet is that I found years ago a description of what was called the Martini Diet. It was supposed to be a way of losing a lot of weight, and it was based on the fact that a martini is consumed cold. You have ice in it. And if our bodies are to maintain a constant temperature, we have to warm up anything that we eat or drink to body temperature, and that requires energy in order to do. We can calculate how much energy that's going to take if we know the size of the martini and the temperature of the martini. A martini with ice in it is going to be 0 degrees Celsius. If there's both ice and water present at the same time, then we know the temperature is 0 degrees. We also know that body temperature is 37 degrees Celsius. You might be more familiar with this in degrees Fahrenheit at about 98.6, but that comes out to 37.0 degrees Celsius. So that means this martini is going to start out at 0 degrees, and we're going to have to warm it up to body temperature, 37 degrees. So we're going to have a 37 degree Celsius change in temperature. If this is a nice big watery martini, like I like to drink it, with plenty of ice and lemon and way more vermouth than gin, then my version of it is going to be about 200 milliliters. So if I take this 37 degrees times 200 milliliters, then I will figure out how many calories I'm going to need to heat up that martini. So 37 times 200 is going to give me 7,400. Now, 7,400 calories is a lot of energy. But how much energy does the martini give me in the first place? If I look up in a diet book based on my watery recipe that I just described, then I find that it will tell me that martini has 200 calories total. So, by drinking that martini, I take in 200 calories, and it costs me 7,400 calories to warm it up to body temperature. If the math here is correct, then it means I should be able to sit by the pool drinking martinis and the fat should just melt away. I think you know already, perhaps you've seen people try, this technique does not work. You do not melt the fat away by sitting around drinking martinis all day. But what's wrong with the calculations? There's one key thing that I did here that you may or may not have noticed. When I gave the definition for calorie, I used a lowercase c. When I wrote the total number of calories that I need to heat up that martini, I used a lowercase c. But when I switched to the diet book, I switched to a capital C. And it turns out there's a difference between capital C calories and lowercase c calories. One capital C calorie is actually equal to 1 kilocalorie, which is equal to 1,000 lowercase c calories. So if I were to convert this to the same units that I was dealing with before, that wouldn't be 200 calories. It would be 200,000 calories. I actually do use 7,400 lowercase c calories in order to heat up that martini. But in drinking it, it gives me 200,000 lowercase c calories. This is why the amount that I have to heat up the martini is negligible, and it's not going to lead to weight loss. So if you've seen similar kinds of things like the beer diet or the ice cream diet on the internet, and they've used bad calculations to try to tell you how much this is going to cause you to lose, forget it. It's all bullshit. It turns out the food energy is so much higher than the energy that it takes just to warm up this small amount of food that the temperature ends up being almost unimportant. But it still matters. What if I were to change this around? Suppose instead of trying to lose weight by drinking martinis, I decided to give up on my alcohol fantasies and just drink ice water. So here's how I'm going to put together this ice water diet. I want to eat some kind of treat. Now, one of my favorite treats, back when I still ate ice cream, used to be to eat a pint of Ben & Jerry's. I liked to eat a whole pint by myself, which I could only do if my wife was away for the weekend. If she was home, then I'd only be able to get to eat half a pint. But suppose I wanted to eat a whole pint of it myself. The question is, how much ice water would I have to drink in order to offset the number of calories that I got from that pint of Ben & Jerry's ice cream? So let's calculate what that would be. So notice that on the label, it tells me that there are 360 calories per serving. Notice that it's capital C calories. It's always capital C calories on a nutrition label. even if your nutrition label happens to incorrectly list it with lowercase c calories, that sometimes happens, it's always actually kilocalories, not calories. So make sure you don't make that mistake. So my number of kilocalories per serving here, I'll just fill in, is 360. And I'm actually going to eat a pint of this, and according to the label it tells me that there are 4 kilocalories per serving, or excuse me, 4 servings per container. So in order to figure out the total number of calories, I'm going to have to take my 360 times 4. I'm going to get 1,440 calories from eating this. But remember, that's kilocalories. Let's convert that to actual calories. To do that, I multiply by 1,000 calories per kilocalorie, and the total calories that I am getting from eating this pint of Ben & Jerry's is 1,440,000. So, how much ice water would I have to drink? Well, we know that each milliliter of ice water is going to cost me 37 calories, because I have to raise it from 0 degrees to 37 degrees. So what I need to do now is divide this by 37, and that will tell me the milliliters of ice water that I would have to drink. So, my 1,440,000 divided by 37 will give me 38,919. That's the number of milliliters of ice water that I have to drink. Now, it's easy enough to convert that into liters, because we know that there are 1,000 milliliters in a liter. So that's 38.9 liters of ice water. That's how much I would have to drink. If you are not used to thinking in liters, let's convert this into gallons. There are 3.78 liters per gallon, so I'm going to divide by 3.78, and that tells me I'm going to need 10.3 gallons. So let me just be very clear. I am not suggesting that anybody drink 10.3 gallons of water or ice water or anything else. If you were to try to do that, it would wash the electrolytes out of your body. It would actually kill you to drink that much water. So this is not a practical diet at all, this ice water diet. But what I want you to see is how much energy. Can you imagine? This pint of ice cream has enough energy to take a little over 10 gallons of water from ice water temperature up to hot tub temperature. That's an enormous amount of energy in food. And that is one of the main things that we're eating food for, that energy. There's a huge amount of it. And it turns out the vast majority of that energy, usually about 80% of it, is used by your body just to keep warm. People imagine that exercise is an important part of energy expenditure, and it's really not that big a deal. All of the activity that you do in a day's time adds up to somewhere around 20 to 25%, depending on how active you are. Could be as low as 10% if you're a very sedentary person, of the total energy. The vast majority of the energy is actually spent in heating your body to keep it warm.